A single ordinary fair die is tossed twice. Okay. Let E be the event that the number that comes up on the second toss is at least twice the number that comes up on the first toss. I smell some cases coming up. And F is the event that the first toss is odd and is less than the second toss. Okay. Find the probability of E, find the probability of F. And then what is the probability that the event E and or F go? So that's now somebody's asking me about a union. Okay. Somebody's asking me about a union there. Okay. So just thinking ahead to B part, we know some of our formulas. And I could use what I've learned in part A and then get rid of the probability of both those things happening. Although if the first one is less than the second, no, they could still both happen. Okay, so for something like this, two coin tosses, that's not too bad. Or sorry, not coin tosses, dice roll. Okay, so we should know that dice are six-sided. So 6 outcomes. Okay, so there's 6 possible choices. Well, no, let's go through it a little slower. Oops, wrong one. Okay, so the probability of our first event is going to be, well, the number of ways to get whatever it was the first event was called. So the number that comes up on the second dice is at least twice. So second is at least twice the first. I'm just going to abbreviate it like that. Over just the total number of ways the dice can come up. So as usual, the bottom number is the easiest one to work out. There's 6 possible outcomes for the first die times 6 possible outcomes for the second die. That's 36. And 36 is kind of small, so we can actually write this out. Okay. So we could say the first die rolls a. Let's make a better picture. Okay. We'll have the first die and we'll have the second die. So the first die rolls a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Or the second die rolls a 1, a 2, a 3, a 4, a 5, or a 6. And I'm going to get 36 different possible squares here. And so I can visualize. So if the first die rolls a 3 and the second die rolls a 4, that's what this little box is representing. Okay, so you can be very visual with something like this. You don't have to do it, but it breaks it up from the usual sort of counting arguments. So these are all 36 possible situations. Okay. What do I want for the probability? I'd like to know the number of different ways where the second die rolls up twice the first die. Okay. So if the first die rolls a 1, the second die, could it roll a 1? No, but it could roll a 2. 3 is more than twice 1. 4, 5, 6. If the first die rolls a 2, the second die, well, it can't have a 1, because 1 isn't twice 2, or 2, or 3. It could be a 4, or a 5, or a 6. If the first die rolls a 3, what possible rolls could the second die have? It's got to be at least twice the 3, so it's got to be at least 6. And if the first die rolls a 4, 5, or 6, none of these possible second die rolls will count. So here, visually, rather than using some sort of counting argument, I can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 different possible ways. Use a different color here. 9 different possible ways to have the second die roll at least twice the first. Out of the total, and again we visualize these squares, 36. That actually simplifies to 1/4. Okay, so that's a different way of looking at a question like this. How about F? What is F asking me to do? So I need the number of ways to roll 2 dice, and that's going to go on the bottom. But what is F actually asking for? What is the specific condition of F? The first toss is odd and less than the second toss. So the number of ways where the first is odd, and first is less than the second toss. Okay, we can go back and visualize that again. Let's pick a different color. So the first die is odd, so we can only be looking at 1s, 3s, or 5s. And we want the first die to be less than the second one. So we could have 1. So if the first die is a 1, we could have the second die be a 2, a 3, a 4, a 5. Any of those are bigger, and so the first die is less. If the first die rolls a 3, well, we could have the second die be a 4, a 5, or a 6. If the first die rolls a 5, I still need the second die to be bigger. I need to roll a 6 there. And so once again, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9 possible ways to do that again, out of the total 36. But you can see while doing this, I've also really neatly set up, visually, the intersection. When can both E and F happen at the same time? Well, whenever I shaded both pink and blue. 6 times. And that'll help me with part B. Okay. So I can see with my nice sort of visual work that both of these are 9 out of 36, or 1/4. Each will happen 1/4 of the time. Okay, now if I want the probability of E or F occurring, I could use a formula. I don't have to. I'll show how to do that in a moment. But I know the probability of E. I know the probability of F. And visually I can see, well, if something I highlighted, if one of these cases of rolling the dice was pink and one of them was blue, then that means both E and F were occurring, and that happened 6 out of the total 36 times. All right, so we could work with that. We get a probability of 1/3, but we can actually be even smarter than that. We want E or F to happen, so which of these boxes got highlighted? Okay, this is E or F, this is E or F. In fact, this is both of them. But this is an E or F. Okay, this is an E or F. So how many of these how many boxes got highlighted, period? A total of 12 of them. 12 out of 36. So we can actually just compute this directly. So I don't get to do this very often, this nice visualization, but it breaks up sort of some of the monotony of, oh, I got to do factorials, I got to do selection with replacement, and so on. It'd be very nice. So we get 1/3 either way. Nice.